Hello everyone, Mr. Zamora here with some challenges for finding the equation of a polynomial given the graph. And this is a good, healthy challenge that brings together a lot of the things that we've learned as far as zeros go. And let's try it out. So here we have a polynomial, and it looks like the left end behavior is going to go towards positive infinity, while the right end behavior goes down towards negative infinity. All right. So we can, it's a challenge. We're trying to find its equation. All we're given is the graph. We can make a decision that it's going to be a cubic polynomial. The next thing is, I see that I have a real zero at x equals 2. I also see that I've got a real zero at x equals -5. Now, if I start writing my equation, well, and let me pause so that I can write this equation out because this has a bad lag to it. Right, so I can't write with the pen. Let's see what we can figure out. We know that this function has a 0 at -5 and at +2. So let's try out x. Well, if I have a 0 at -5, that must mean my root is x plus 5. So we've learned that if I know the zeros, then I know the factors, right? And then we can try x minus 2. And I've come up with a function with the same two zeros, but it's not really even the same degree. I came up with a quadratic. I need a cubic. So that leads us to the conversation of, well, let's really think about this 0. This 0 is touching the x-axis, which means that it has something that we call multiplicity. That's good to know. This has a multiplicity of 2. In other words, that 0 at x equals -5, it really counts twice. This is really x plus 5 times x plus 5 times x minus 2. And now I've got myself a cubic function. You notice your cubic function is sort of pointing in the wrong direction. Its end behavior is backwards. The left end goes down to negative infinity. The right end is going up to positive infinity. And I can zoom out a little bit. So we're going to experiment a little bit with a negative. And if I put a negative, now I'm really approaching actually what this function looks like. Okay. So instead of guessing at what number it needs to go there, I'm going to determine that this needs a coefficient a. Right? And I'm actually going to add the slider a. All right. Now, the more positive I make my slider, we know that's not going to work. We discovered a second ago it needs to be negative. So I'm going to explore with this, and it looks like the closer I get my a value to, I bet it's -2. Boom, -2. That will actually be the equation. So let me see what I've got. So I've determined this is y equals -2 times x plus 5. You don't have to write x plus 5 twice. You can just say x plus 5 quantity squared times x minus 2. And I'm going to peek at my answer. And guess what? That is the correct equation for this function. So let's talk a little bit about how I can find that value -2, because that was really the catch. I found it using the slider, which is really just technological guess and check. But how do I actually find that number? All right, well, here's a tip. Let me see if I can write something down for you. Right, so voila, here's some work. To algebraically find that value of a without using a slider, what we would need to utilize is a coordinate that we know, and we don't want to use our 0 coordinates. We don't want to use the zeros in the problem because they'll end up giving us outputs of 0. So I chose the y-intercept of this function. The y-intercept is 0, 100. So because that is an x-y combination, right? Because that is x-y, then all I did is I substituted 100 for y and 0 for x in my function, and then solved so that I could find the value of a. So when I do this, I have 5 squared, and that's 25. 25 times -2 is